What's up, class? Hope you had a good New Year and Christmas. This is Mr. Weckesser, and I'm teaching you 3.5 today. Hopefully everything works. We're doing systems with three variables. So let's go through this and define a couple things first. See if my marker works. Good. Remember, a system is just an equation, right? And we're doing equations that are in standard form. We have to remember what standard form is. But before we do that, it'll be down here a little further, I think. But let's talk about three variables, and it's also defined down here a little further. Three variables we're going to use normally will be x, y, and z. And you're going to be able to graph those like that. And there are three coordinates, which is described a little bit down here further. So let's go through this. Vocabulary. Review. Circle the number of points that determine a plane, right? And a plane is a three-dimensional space, and you probably don't remember too much about this, but a lot of times it looks like this kind of area, and it's three-dimensional, and it's hard to describe, hard to envision unless you actually look at a video with it, which we're not going to do today. But we have 3 points in three-dimensional planes. So vocabulary builder, an ordered triple, and that's what it says here. Ordered triple is our first word. Definition: an ordered triple is x, y, and z. Has 3 coordinates and describes a point in a three-dimensional space. Main idea: the first coordinate of an ordered triple represents the point's location on the x-axis. And these are all alphabetical. Like I said before, it looks like this. First point is x. The second coordinate location is the y-axis. And here's y. Remember, so we have x goes this way, y goes up and down. So now we have something different. And the third coordinate is the location on the z-axis. And here's what it looks like when you graph it. X, Y, Z. Alphabetical, like most things in math class. So that's all we're going to discuss. I could go in detail about this and what the z-axis is, but we're not going to do that today. Or use your vocabulary. Circle the ordered triple that has an x coordinate of 0. So we're looking at the first number here. Is x, y, z, right? That's what we set up here. So here's the x. And that one has a 0 right there. 0, 1, 1. So here's the x is 0, the y is 1, the z is 1. So you're going to circle that guy right there. Problem 1, solving a system using elimination method. And we did this before, and I told you this is my favorite part of math because you get to use different ideas, and it's abstract, and you get to solve. I feel like you solve for the first time ever for something real. And this is why it's real. This is 3 systems. So what is the solution of the system at the right? Use elimination, right? Check your answer in all 3 original equations. So you got to check it too, it says. So some of these problems we're going to be doing in class and on your worksheet for homework tomorrow involve about a half a page or sometimes a full page of work. And it's tedious and it's long, but for me, it's a lot of fun. And so hopefully you can enjoy it a little bit, but tomorrow's homework's not going to be much because it's a lot of work. If you make one mistake, the whole problem ends up being wrong and you get frustrated. So we're going to grade each line as a point of work. So if you mess up one line, you only get 1 point off. So that'll be easier for you. That's how I've always graded it because that's how it should be. So if there's 30 lines of work, which a lot of times there are in these kind of problems, you miss one answer, you only get one part of the question. You still get a 29 out of 30. So number 3, okay, how can you combine and number 2, eliminate a y? So add 2 and 1 or subtract 2 and 1. So here's 2 and 1. How can you get rid of the y? Here's the y right here. So if you add those together, a negative y plus a y, you get 0 y's. So that's the answer number 3 here. Number 4, how can you combine 2 and 3 to eliminate y? Right? Again, exact same thing. You can add these two and eliminate the y. So now we got rid of the y's. So we're going to combine 1 and 2 to eliminate y. Okay, so here it is. So we get 2x, right? And then we have, this is a minus here. This is confusing because there's big spaces here. There's big spaces here, right here. See these big spaces? You're going to just pretend that those spaces aren't there. I don't know why they're there. But you have a negative y here and a positive y. When you add those, I put a plus sign here, by the way. They did not do this for these notes, but I always put the plus sign there to help me out. Because sometimes you track, sometimes you add. We're not going to subtract, we're going to add today. So you have 0y here. Z plus 3z is 4z. And then you have a negative 1 here plus a negative 3, you have negative 4. So now we've combined those two equations. And so that's what you're going to do for these. When you have 3 equations, you're going to combine usually the top 2 and then the bottom 2. You're going to make just 2 equations. And then when you get from 2 equations with 2 variables, because we're getting rid of the y first, right? You're going to go to 1 equation with 1 variable. And that's when you have the answer. So we already eliminated the y from the first 2. Now we're going to eliminate the y from the second 2. Like I said before, we said we're going to add. So we're going to add here an x plus 2x, right here, straight down is 3x. Then you have a plus y here and a negative y here. So a y plus a negative y is 0y. Then you have 3z plus 2z. You get 5z. And then we have negative 3 plus 0, and you get negative 3. So now we have 2 equations with 2 variables. We've gotten rid of the y's on both of these. Okay, so let's scroll up on the screen here. Hopefully I can do this. There we go. Zoom back out. So use the equations from exercise 5 and 6 to write and solve a system of 2 equations in 2 variables. Okay, and this is when I said there's a lot of work, and it is true. There's a lot of work. So we have, and these are all sample questions here because you have a lot of stuff here. So remember, we have this first equation here. We're going to write down here. We have 2x plus 4z equals negative 4, right? And then over here, you have 3x plus 5z equals negative 3. And we're going to zoom this guy down here too. So 3x plus 5z equals negative 3. And so it looks like from just by looking at the equation, what they did was they actually solved the equation here. And so, because there's a lot of 2's right here in this first one, so to solve this one, this guy decided to solve for x by getting rid of the 2's. So he divided by everything by 2 first, which you're allowed to do in the equation, right? So he got x plus 2z equals negative 2, right? 4 divided by 2 is 2. Negative 4 divided by 2 is, this is a 2, by the way, 2. And 2x divided by 2 is x. And then he solved for the just x. You want to get x by itself, right? And to get x by itself, you need to get rid of this 2z on each side. So you have x equals negative 2z minus 2. So now we solve for x. We know what x equals, kind of. But now we're going to plug this in to this other equation right over here, where x is. And we're going to plug it in and solve for z. So we'll get rid of z, because all we have is z here, right here. So we have 3 times negative 2z minus 2, bring down to 5z, equals negative 3. And if you're confused by now, that is very natural. That's okay. This is a lot of work and a lot of solving just to get one variable, and then we got to solve for the other two variables. This is why it's a half a page to a full page of work many times. So now we're going to use basic math. We're going to distribute. So we have negative 6z, 3 times negative 2 is negative 6, plus 5z equals negative 3, right? So now we're just going to solve this for z. And we have, this is probably two things you can combine here, right? So we're going to add 6 to each side first. So now you get 6z, negative 6z, plus 5z is negative z equals negative 3 plus 6 is positive 3. So to get rid of that negative sign, we've learned to just divide by negative in each side. So positive z equals negative 3. I was right the first time, sorry. Let's cross that all off. Z equals negative 3. So we know what z equals now. So we can put that up here as our answer, right? Z is negative 3. We need to solve for x and y. Remember, x, y, z are your coordinates. So let's solve for another variable. You can solve for x or y next. And so you just gotta plug in z, and that's the easiest part. So the easiest variable to solve, the book says, is this one right here. This is the smallest variable to solve for x. So all we do is going to plug in this 2x plus 4z, which we know z is what now? Negative 3. So that's going to go here, right? Equals negative 4. And this whole equation is from this over here. We just took this guy and put it over there. So we have 2x now plus a negative 12 equals negative 4. Add 12 to each side. 2x equals negative 4 plus 12 is 8. We're going to divide by 2. You get x by himself. X now equals 8 divided by 2 is 4. Okay, so we have x and we have z. Now we have to solve for y. So we need to go to an equation that has a y in it and plug in the x and a z. So let's zoom back up. Right to the beginning part, all the way to the beginning part. And the easiest equation up here of all of these has at least now numbers in it is the first one. X minus y plus z equals negative 1. So we're going to use that guy. Scroll back up. Come on, paper. There it is. Okay, so number 8. Use the solutions from 7 and 8. 7 and number 1 to substitute x or solve for y, and that's what we're going to do. So we're going to take that first equation we did. Remember, this is like a page of work. And we're going to rewrite that. X minus y plus z equals negative 1. And now we're going to plug in the x in the x is 4, right? And the z is negative 3. We're going to plug these two in for here to solve for the last one of y. So x is 4. So instead of putting x, we're going to put 4 down. Minus y, because we don't know what y is yet, plus z. And z is negative 3 equals negative 1. So what can we combine? We combined the 4 and the negative 3. And 4 minus 3 is just 1. So we have 1 minus y equals negative 1. Correct? So what we need to do now is get the 1 over there. So we're going to subtract 1 from each side. So we're going to move our work up here now. So you have negative y still. And then you have -1 minus 1 is -2. To get rid of the negative y, we must divide by -1 from each side. The negatives cancel. So y is going to equal -2 divided by -1 is a +2. So now we have our solution. The solution is x is 4, y is 2, and z is -3. And if you're confused, that is okay. I'm not expecting you to master this at all. It's just an introduction to 3, right? 3 variables, 3 systems. It's very confusing, I know. The system was 3 variables. Okay. Now he says we want you to check your work in all 3 original questions. And you can do this. You can plug all the numbers in all these and find the answer and make sure you got them. So if we did this one, it's -1 equals -1. It's a check. I'm not going to do all the work because I don't want you guys to spend all this time. But that one works too. And then the last one, I did the work. It's 0 equals 0. And that's a check. So we solved all of those. So problem 2, solving the equivalent system. What is the solution of the system at the right? Use elimination. Okay, so like I said before, there's a lot of work involved with these questions, so we're not going to do all of them, but you can do the first 2 at least, and we'll do this one, and then we're not going to do problem 3 and 4, because 3 is a substitution problem. It's a lot of work, and 4 is a real life problem, which I'll just talk about, but I'm not going to, and give you the answers. I'm not going to expect you to do all of that. So first, add or multiply of 1 and 2 to eliminate x. Circle the number you will use to multiply number 1 by. Okay, so they want you to eliminate x for 1 and 2. Here's 1 and 2, right here. So they want you to multiply x by a number in order to get rid of that. So in order to get rid of the x here and the x here, they have to be the same number. So what should you multiply by? Well, the answer is -2. Because you want to add them together, it says. And if you can multiply this by -2 here, it becomes a -2. A -2 plus a +2 here eliminates the x. And that's the purpose of this whole problem. Number 12. Next, add a multiple of 2 and 3. So this is questions 2 and 3. Here we go. Here's 2 and 3. Right? So this will be -2 here. By the way, let's just do that real quick. To eliminate x for 2 and 3. Circle the number you will use to multiply the second question by. So you're going to multiply this top one, right, by -1 in order to add these together to get rid of it, right? The second and third equations right here. So that is an option. You can do that. Another option you can do is, instead of adding those equations together, you can also subtract those 2 equations. And I'm going to show you how to subtract them. It's the exact same thing as adding. You just subtract 2x minus 2x and you get 0x. But they like to only add these, so the book is going to teach you just to add. And that's why the -1 is the answer for this one. Okay, write the 2 equations you get by eliminating x. So we're going to eliminate x. And write the 2 equations down. We're going to skip some steps here. So we have 3y plus a -8z equals -19. And the other equation is 3y plus 1z equals -1. Number 14, now find the solution to the 2 variable system of equations. So we're going to write all this work down. It's a lot of work, so bear with me. You have 3y minus 8z equals -19. And then you have negative, right, 3y plus z equals -1. It looks like that, right? When you subtract them, and that's why it has a negative right here, because you're subtracting them. So you have 3y's, they cross off. -8z minus z is -9z. You have -19 minus a -1, and that's like same thing as adding the opposite. So you're going to add -1, so you get -18. And now you have a pretty number because you have a 9 and 18. You know 9 goes in 18 2 times. So divide by 9, negative 9. You get z by himself now. Negative 18 divided by negative 9 is just 2. There we go. Now, let's go to the second part here. We're going to solve for y. So you have 3y plus z equals negative 1. I put the z here like this always, so you can discriminate that from, this is the letter, from the number. I try to write with a loop. If you don't write the loop, you get the two numbers and letters, the number and letter mixed up a little bit. So this is the number here, or hashtag. It's also the number sign. You have 3y plus 1 times 2 equals negative 1. Why is this a 2? Because we know that z is 2. And so that's even more confusing because we have a 2 equals a 2 or a z equals z if you see it that weird way. But don't see it that weird way. Make sure you know this is the letter and this is the number. So now you combine these. You have 3y plus 2 equals negative 1. Subtract 2 from each side. You have 3y equals negative 3. Divide by 3. And y equals negative 1 now. So we have 2 of the answers. Now we're looking to solve for x. Number 15, substitute the values of y and z into the first equation to solve for x. So here we go. X minus 2y plus 3z equals 12. X minus 2 times negative 1 plus 3 times 2 equals 12. And why do we do this? Because we know that y equals negative 1. We know z equals 2. So we combine everything now. So we have x, and a negative 2 times a negative 1 is a positive 2. A 3 times a 2 is a 6 equals 12. Now it's going to come together. 2 plus 6 is 8. Get rid of the 8. X equals 12 minus 8 is 4. So now we have all 3 answers. We have a 2, a negative 1, and a 4. If you put it in order, it'll be 4, negative 1, 2. All right, let's go up. It actually didn't ask you to do anything for that one. That's all they ask you to do. So there's no other work. Usually there's a line, you put these numbers right here in, but there's no line for that. So we're just going to circle that and make sure we know the answer. Number 3, solve a system using substitution. I'm not going to do that because we're not going to do substitution for 3 variables. That's just way too crazy. It's not actually beneficial at all. So we're going to skip that whole problem. You can just put an X through all this. So if you want to know the answer, it's right here, 2, 1, and negative 4. If you want to do that work on your own, I'll give you bonus points for that, actually, if you get the right answer. That'll be fun for you. Okay, number 4, I'm just going to talk about it because it's a real-world problem. We're not going to actually do it. Business, you manage a clothing store and budget $5,400 to restock 200 shirts. You can buy t-shirts for $12 each, polo shirts for $24 each, and rugby shirts for $36 each. If you want to have the same number of t-shirts as polo shirts, how many of each type of shirt should you buy? It's really expensive, I feel like. Like usually you buy bulk t-shirts and stuff. There's no way it's $12. I mean, you could sell them for $12 a piece, but usually you can buy them for $2 to $3 to $4 to $5 and sell them for twice as much. I mean, these are really expensive shirts if you're a business person. So I'm flabbergasted by those prices if you buy in bulk. So the question says, if you want to have the same number of t-shirts as polo shirts, how many of each type of shirt should you buy? And they say this is a real world problem. I disagree. So I don't know why you'd want to have the same number of shirts. Just order the same number of shirts. So we're going to skip this one. Not real world at all. Number 20, circle the method you will use to solve the system. You have two methods, elimination and substitution here, actually. That's why it's fun. If you want to solve it, you can. I'll give you the answers. Put your work in that space there. It's supposed to be 50 t-shirts and 50 polo shirts. And you get 100 rugby shirts. Lesson check. Okay. So the last part. How many solutions does the system at the right have? Explain your answer in terms of intersecting planes. Solve the system by adding 1 and 2 and then adding 3. So they want you adding these together and then add 3 to that. And so you can do that like I taught you before. I'm going to put this here, and I'd like you to bring the work in next week and show me that you added these together. So we're going to put them on top of each other, just like you would add anything growing up when you're in grade school, when you added numbers, right? Put them like this, and the book doesn't have this, but I like to put the plus sign there. So we're going to add these together. So 2x plus 2x, you have something x. Put that answer down there. Negative 3x, negative 3y plus negative 3y equals what? How many y's are there? Put the answer there. And z plus z equals how many z's? Put the answer there. 5 plus a negative 2 is 3, right? So what they want you doing is getting that answer, right? And then adding it to number 3, okay? So when you add it to number 3, I'll give you the hint right here. It's 4x minus 6y plus 2z equals 3. And then it's negative 4x. Here's the negative 4x one. Plus 6y minus 2z equals 10. And this is where it gets crazy, because it's 4x minus 4x. You have 0 x's. Negative 6y minus 6y, right? It's actually a plus here. 4x plus a negative 4x is 0 x's. Negative 6y plus 6y is 0y. So we eliminated 2 of them. Then we have a 2z plus a negative 2z. You get actually plus 0z. Then 3 plus 10 is 13. So you actually have nothing here, nothing here, nothing here. You have 0 equals 13. When 0 equals 13, we know that their system has 0 solutions. And that's a possibility sometimes, right? It's a possibility when you get answers like this. The graphs of the 3 equations are they intersecting, parallel, or perpendicular. When they're not, there's no solutions. We learned this before. They're going to be what? Parallel. So all these graphs right here have the same slope. They have the same slope. That's craziness. So a same slope means parallel. That's awesomeness. Okay, that's it for chapter 3.5. I know it's a lot of notes. Write those down. Turn those in when you get back next week. And hopefully you're enjoying your break. And I'll see you then.